So today, hope I have that open here. Just really want to make sure that the stuff that we're doing right now makes sense. So we'll just clarify the assignment that we did uh, on Tuesday, and then we'll talk about the assignment that we're doing today, and I'll do a little bit of an intro or precursor to what we'll be doing on Friday, since we won't be meeting Friday uh, with a live synchronous session. So try to make sure that we have everything set up. All right. So, some of you were here, most of you were here on Monday also, where we went through and we talked about this assignment. This is the one that was assigned on Monday. Um, or pardon, yeah, was that? Oh, Tuesdays is kind of like Fridays last week, so that's what it was. So we went through something similar to this on Monday, but there were a few folks that didn't quite see everything. Um, I don't know. Is there? Yeah, I wish there was a way to move this thing. Um, so we'll discuss this a little bit. There are a couple of small changes from this compared to the one from Friday last week. Uh, and then we'll take a look at the assignment that was posted for today and discuss what the deal is for tomorrow. So um, when you open up, let's see, this day one home circuits, when you open that up, you should see something that looks kind of like this, just floop, home circuits. And there's nothing to do on this tab. So with spreadsheets, things that can do calculations and graphing and stuff like that, they generally have additional tabs on the bottom of the spreadsheet that are just spreadsheet tabs, not going to different pages on the interwebs. So down here, there are a few different tabs that we can go to, and this tab, collect and calculate data, is the tab that we need to refer to. My dog is outside barking. I'll see if I can get him to stop it. Hey, bud. Come here. Come in. Here you go. Special guest shot. There's Chewy. Arr, 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 arr. There. Good boy, buddy. He's wondering what the heck that's about. I don't normally pick him up when he comes in. uh, so my apologies for that. For the delay. No apologies for picking up and loving on a dog. He's a good boy. Um, the collect, calculate data tab, appliance data tab. These things are on the bottom for you guys. And so this calculate tab is where you would go to enter your data. So iron, the electric potential or plugging in iron into an outlet is 120 volts. The power rating, you should be able to just check on your iron, look on the back where the cord attaches to the iron, find the rating there. And if you don't have that, or if you don't know where your parents keep the iron, or different things like that, if you don't feel like running around the house and checking, you can click on appliance data here, or down here. And these all pretty much just take you to the Target website. I tried a few different places, but Target was the one that had the most consistent place that we could check data. So you'd go here, open the stuff for the iron, then you'd pick an iron. Come on. We're shopping in Shoreview. And once you pick an iron, you can scroll down, and then there's like a little tab or a little button that says show more data or show more or something like that. So if I click on this one, it's the first one there. $24.99. Scroll down. Bloop, bloop. This thing is on details, and then down here there's show more. And then down in here, they call it, instead of saying power rating, they say wattage, but same sort of thing. So the power rating or the wattage for this iron is 1200 watts. So I just clicked back on the assignment sheet, go back to calculate and collect data, and I would say, hey, that iron and I would just punch in 1200. There you go. If I put in the letter W for watts, then everything is all buggered up. Don't do that. Just numbers. Then the spreadsheet can go through and do calculations and can make sure everything works okay for us. Then down here, you'll notice that the 1200 that I put up there magically appears here. And if I'm going to find current, bloop, 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 there are a couple of different ways, well, several ways to calculate current, just a couple that we've discussed. One is to take power and divide by voltage, or it's to take power and divide by electric potential. And another is to take current, or to say that current equals the potential difference divided by the resistance. Well, at this point, we don't have any resistance values, so this version with potential difference and resistance doesn't work so well, but this power divided by potential difference does. So if I do 1200 divided by 120, or 1200 divided by 120, I get 10. Enter. Blah. The cell turns green. That should be a sign that we have the right answer. There are a couple down here that I think it was the water heater and maybe the clothes dryer that don't turn green, but you should still notice your score at the top improving if you get those right. I'm going to go through and double check people's scores on those to make sure that the auto calculate thing works out okay. There you go. Sorry about that. So I'll go through and make sure that the auto calculate has done everything correctly and that you're not short at any points. We'll take care of you. And then after that, we move on down to the resistance stuff down here. And you'll notice that the 1200 that we put in for the iron up on the top part is present again. And it copied down the 10 amps of current again. And then if we're going to try to find the resistance, then we can go down here. I tried to put the equations all on the side here. And we can use this relationship. The relationship between current, potential difference, and resistance is often called Ohm's law. And we can rearrange this and get resistance on one side. And then the resistance is the potential difference divided by the current. So that would be 120 divided by 10. And 120 divided by 10, 1.2. Is that right? No. 12. Sorry. Okay. Brain cramp there. And enter. Right. And if I put in instead, if I mistakenly put in 11, then no longer the background doesn't change. So, so that does kind of take care of itself, or at least shows us when we're getting things right or wrong. Again, on the resistance one, I think it's the water heater and the electric furnace or the clothes dryer. It might be the clothes dryer. Those two of them down here, again, don't change color. So there's the quick review. Well, there's the review. I don't know how quick of the first home circuits thing. I'll give a couple of seconds here and allow for questions. I'm going to let there be silence if you to kind of make sure we've got it. So right now, ask questions on this if you have them. After a minute or two, or after questions are done, we'll go on and we'll take a look at the assignment for today. So questions on this? Any questions? Okay. We're all just really excited. We don't want to talk about this. We want to talk about the Vikings signing Tomlinson and Patrick Peterson on one-year deals to shore up the defense. And now we're ready to draft the offensive lineman and speed rusher on the corner. Is everybody just too excited about that to think about this assignment? That's what I thought. Yeah. Yeah, I agree. Pretty exciting stuff. That's the skull horn, just so you know. Okay, so that's all of this home circuit stuff for day one. For day two, um, we're going to use some of this data. So you should be able to kind of find your data here and copy and paste it, hopefully, over here. When you're ready to paste it, it might ask if you want to link it to the spreadsheet. Say no, don't link it. And there are some things that I removed. So pasting might be a little bit different here. So in this column, I removed all of the items that are 240, that use 240 volts instead of 120. Initially, I thought that would be a nice way to kind of look at how some things work in series versus parallel, including like fuses and circuit breakers. But as I was trying to make this make any sense at all, that was just like one more level of challenge to make it understandable just in conversation, right? You're all capable of doing that separate work, but it was really difficult to try to find ways to word things that made sense without being able to like, oh, here, see this thingy. So I just got rid of all the 240s to streamline things a little bit. So with this stuff, oops, just moved that. Control Z, there we go. With this stuff, then, you should be able to take either the current data that you had from that other spot and put those things in here. And it's fine by me if you round numbers off, and the assignment sheets, these sheets, work okay if you round things off too. I have things set up so if you round down or round up, as long as you only go to the ones spot, it should still work. So rounding things off is perfectly fine. So I went through and I have a copy version here. So for one version, I have the current values lined up here, and then I was starting to enter the resistance values here. And we'll go through and we'll talk about how to kind of go through and do this part. So we'll try to clarify some of this stuff. So in your home, you know, the energy company has electrical wires kind of coming into the house. Then there's a big box, and things kind of branch off of that, right? And so off of that, there'll be maybe a main line that goes maybe towards your kitchen, maybe another main line that goes towards the laundry room, and then maybe a third line that goes to like bedrooms and outlets and stuff like that. Ballparkish, just rounding, just generally. And then each of those lines, like if we say the line that goes to your kitchen, there's the line that goes to your kitchen, and then that will also split off, and it'll have one section go towards like the oven, one section go towards the fridge, maybe one section go towards the kitchen lights, maybe one section go towards the dishwasher, stuff like that, maybe another section go to outlets. But all of that stuff kind of is branched off of one route. Yeah. So there's the box, and then a sprout coming out that goes to the kitchen, and then that one sprouts off and goes. This one will go to the fridge and bring it back to the power source. This one will go to the outlets and then go back to the circuit box. This one will go to the lights and back, but all of them are on this same kind of primary branch off of that power, off of your circuit box. Let that digest for a second. So we have that one arm, and kind of like an arm, right? Big arm going through, leaving the circuit box, and then maybe fridge, and then back to power, maybe outlets back to power, maybe dishwasher back to power. Did I say lights, stove, stuff like that, right? And every one of those then goes back off. So this is a lot like kind of the junction rule sort of stuff, right? So whatever current is used by all of these different circuits must go through this branch. And this wire can only take so much current before it melts, before it gets hot and maybe melts the insulation around the wire. Excuse me. the wire itself, the metal itself, uh, we won't see it get so hot that the metal itself melts, but it'll start to melt the insulation around it, and then we have a risk for the home. So what we're going to try to do is find ways to group all of these different branches so that this wire uh, doesn't get too hot. And what the people building a home do is they just put in fuses or circuit breakers in this main wire, and this fuse will or circuit breaker will basically just turn off this entire set if the current gets too high. So they have then like a current limit. So down here, I just kind of named different branches. I said branch A, that one will have a fuse that stops at 15 amps. So if 15 amps or 16 amps goes through this branch, then that fuse will turn everything off on that branch. Then you need to go down, figure out what was going on to overload that circuit and stop it. And if we say we're going to go with a branch ID for D, then we can say, hey, the combination, that main branch can have up to 20 amps. Now, the more branches you have, the more expensive it costs, the more expensive it is to build everything. So you can't just say, hey, I'm going to put everything on its own fuse. That's kind of expensive. So what we end up trying to do is group things according to both function and maybe location, and then also trying to keep things within like these limits. And so this is based solely on like current and location, right? We don't need to worry about the potential difference. We don't need to worry about the resistance. We just need to worry mainly about current. So if I say, hey, like the bathroom lights, like if we're talking about like the vent, some bathrooms have vents that'll also kick any steam from a shower or a bath or whatever out through a vent. So that would be 13 amps. If I did that with branch A, B, or C, that'd be about all we could put on that branch, and we're kind of done, right? So that doesn't seem like a great way to go. So 15 amps seems like it's probably too small for that. So I would maybe think about going, hey, I'll go with D for 20. Yeah. So if I say I'm going to put this as a on branch D, where the max is 20, bathroom 13 amps. Now we have a few more amps that we could put on there, and this is a light. So I could think about saying, hey, what other light like things, right? Sometimes it's nice to group those things. So if I say the bedroom lights, 2 amps each, that'd be 13, 14, 15, 16, 17. So we're in the neighborhood there where we could kind of say, hey, I'll go with D on those. And now I'm underneath my 20 amp limit, and that can work. Yeah. Um, excuse me. It's conceivable that we could say, hey, these outlets for the game system and the TV, we could put those there too. That's 13, 14, 15, 16, 17, 18, 19. If we do that, we're still under the 20 amps, and that can work. And sometimes people will plan for, well, what are the odds that you have all of those things on at the same time? Sometimes things are arranged differently, but these, it's not unreasonable for all of them to be on at the same time. Um, but that kind of keeps everything within our 20 amps, and we're kind of good. Does that make sense? Okay. Um, and then so now D is used up. I'm not going to put anything more on D. I'm going to look for other things. And it might be helpful to start with like those big current value items. Like the hair dryer, that's in on an outlet, that's at 17. One way to go there. If we did a 20 amper, that would kind of be everything right there. So maybe we'd look at going with the other 30 amp deal. We could throw H on there, and then we could see what else we can put on with this outlet. And let's see, the hair dryer and the iron would probably be plugged into the same spot, right? I mean, you probably, both of those would probably be used. Oh, not iron. I was thinking curling iron. You're not going to probably use the iron in the bathroom. My bad. So the hair dryers at 17. Then we can look to see what other stuff would combine to make sure that we're still staying under 30. So that's the general idea, is to try to make sure that whatever fuse set we're using, we combine these things in a way where they don't go over the fuse limit. Period. Okay, that's the primary goal there. There are other considerations and ways to make things work more smoothly for real home construction, but it turns out we're not really building a home. So, right now, we just want to make sure that this stuff kind of makes sense and that it works at least mathematically. And really, all of this stuff, what we're doing is we're really applying the junction rule, right? Whatever current goes through here splits up. Whatever this total current is here is the total current through these things, and total current into this junction is the same as the total current out of that junction. So we're just really applying that junction rule for current through this stuff. All right. So that's gone. This is. It always takes me a little bit longer than I expect it will, but I want to make sure things make sense. So again, I'll give you a chance if you have questions to ask questions. Thank you. Okay. So then I'll start to talk about what tomorrow's assignment will look like, and tomorrow I'll post another video separately for that, but we're all here, so I think it might be helpful for tomorrow, and this is for tomorrow, so don't plan on doing this today. So tomorrow, what we're going to do is try to actually build the circuits that are based on these things, right? And so, excuse me. So one way to go through and do this, where you can kind of double check things and make sure everything works, is to use the circuit construction thing. So one option is to open up these FET circuits and to try to build everything there and double check and make sure everything works. Another option would be to simply draw out pencil paper. This is what things would look like. This is how my circuit would work. I'm going to show you a FET version because if I write it out pencil paper, it's a little awkward to take a look at. So, excuse me. So what I'm going to do is I'm going to pretend that I just did fictionally. I'm going to use letter, oops, enter. So there is no circuit ID T, right? I'm just choosing another letter that's not in our identification bracket, just so to make sure that you know that this is not one to go with. But if these three things were all on one branch, we would then draw that circuit up, and the way we would do that in FET, we'd say, hey, this is kind of like our power source, like our circuit box. Now, the way electricity moves with those things is a little bit different, but this can work as a way to think about things. So I'm going to say, hey, there's like my circuit box, and this is one branch going out. And now I think we had three things. So I'm going to say this goes to one thing, this goes to the other thing, and this goes to the third item in that list. Yeah. And just to double check, I had bathroom lights, iron, hair dryer, the bathroom lights had 9.2 ohms. So what I'm going to do is I'm going to make the battery 120 volts. Come on. And then I'm going to add a resistor. And I think that resistor, sorry, yeah, you guys were up against time. So if you have to go, you have to go. I understand. And the resistance for the bathroom lights was 9.2. 9.2. And now it's a resistor, but it can represent the bathroom lights. And then I can add this to represent the next thing on the list, which was the iron, and that had a resistance of 13.3 ohms. So I can go here, click on this, make this 13.3, and then that will represent that next item on the circuit. And the last thing, 7.05. Well, I won't be able to get the 0.05. I'll just go 7. And we'll go with that. Clicky. And then that setup can kind of work to see what we've got for those things. There. And now if we do this, we can connect these things all back. And the ammeter, this ammeter, will tell us the total current through here. And that can make sure that we didn't overload whatever fuse we had planned on using there. So, come on. And so that's a lot of current. So that circuit T that I created, maybe not the way to go. But as we're going through with this, we do see, hey, that's 39 amps. We don't have any fuse that hits 39, so this is a bit on the big side. But that's the general way that things would go through and work for what we're doing. I'm just gonna, if I trash that one, oh geez, we're still burning her up. The battery looks hot, but we're down to 22 amps, and like the 30 amp fuse could take that. And the condition that our house would be built with, we would have wires that are thick enough to handle that without burning, and the power box would surely be okay. So that's everything I think that we have for this stuff. If you have questions, let me know. If you want to hang on the line and ask questions, you sure can. I'll have a separate video that goes along with the stuff for tomorrow. I thought this might be a helpful end to today to see where we're going. That's what I got for you. If you have to go, you have to go, as always, right? So thanks for stopping in. If you have questions, let me know. Thank you, guys. Bye. I am turning off the recording, trying to turn off the recording. Oh, for Pete's sakes. Maybe I need to, sometimes the more stuff is running,